Since we have a number of people sick lately, we're going to make a quick video to try and explain the first part of the next chapter. And this next chapter is something that will be totally new to pretty much everybody. It's something that sometimes comes up in geometry books, but we did not do in geometry class. We're going to talk about trigonometry. You should remember that the name of this class is Advanced Algebra and Trigonometry, and now it is time to move from algebra into trig. So we'll look at trigonometry starting today. Something you should remember from geometry class is the idea of similarity or similar shapes. You might remember that was the day that I hauled out the Pepsi stuff and we actually used it for educational reasons and looked at things that were the same shape, but some were big, some were small, they're different sizes. That's the idea of similarity. You should remember that when you have similar shapes, the corresponding angles are always the same, and the corresponding sides are proportional. In the triangles you're looking at here, we have three pairs of congruent angles, angles that are the same. And it should make sense that the sides of the second one are all twice as big as the sides of the first. Well, trigonometry is based on the fact that if you have similar triangles, they're always going to be similar if the angles are the same. You might even remember from geometry class that we had a rule that was called AA that said if you had some angles that were the same, you automatically had similar triangles. And it turns out that because similar triangles are proportional, you could make proportions out of big triangles and small triangles, and they're always going to end up being the same. Now, when we work with triangles in trigonometry, what we most often will work with is right triangles. And hopefully you remember that a right triangle just means you have a right angle in it. You can see four right triangles in this picture. I want to go through some terms that hopefully you remember from the past, one of which is the word hypotenuse. You should remember that the hypotenuse is always the longest side of a right triangle, and it's always across from the right angle. Looking at it as the longest side is usually the easiest way to find what's the hypotenuse. When I went through this in class, I said, so what do you call the other sides of a right triangle? And hopefully you remember those are the legs. Those are the shorter sides of a right triangle, the sides that make the right angle. We call those legs. In trigonometry, we almost always want to tell apart the two different legs. We want to know which one is which. And so to do that, we typically use the words opposite and adjacent. Opposite just means across from, adjacent means next to. And so here you can tell that B is opposite the angle that's marked, and A is adjacent to the angle that's marked. Again, opposite means across from a given angle, and adjacent means right next to the given angle. Of those two, adjacent is usually the one people have more trouble identifying. Remember, we're talking about the adjacent leg. So you're looking for the leg or the shorter side that's next to an angle when it says adjacent. You'll often see questions like this, where we have a triangle and we're trying to figure out how long various things are. Remember, opposite means across from, adjacent means next to. And so you look at the angle that's indicated, you find what's across from that angle, what's next to the angle. And there you can see like 5 is across from A, 12 is the leg that's next to A. Something you'll notice is when you switch from one angle to the other, what's opposite one is adjacent to the other. So there's the answers for that one. Here's another set of problems with sides that measure 60, 91, and 109. And I'll let you look through that for a minute and see if you can figure out what's opposite A, adjacent to A, opposite B, and what's the hypotenuse. And again, there's the different answers for that. Whenever we use terms like opposite and adjacent, and basically in trigonometry in general, we're going to talk about the acute angles. I'm never going to ask you, like, what's opposite C, because it's always just the hypotenuse, and there would be basically two sides that are adjacent to C. So it'll always be the acute angles that you're asked about. The reason why those terms are important is we use them to define what are called the trigonometric ratios. And pretty much everything we do in this chapter is going to be defined around these different trig ratios. You guys have probably seen keys on your calculator that look like what you're seeing on this slide. And what we're going to find out today is where they come from and what they involve. There are three major trig ratios. Technically there's six, but we'll worry about the other ones later. First of them is what is called the sine. The sine is just a fraction that you can make by looking at a triangle and taking the opposite leg over the adjacent leg. I have that same thing basically written three different ways on this slide, but you want to remember sine is opposite over adjacent. All three of these trig ratios are just fractions you make out of the sides of triangles, and they're almost always referred to by abbreviations. So sine, when you write it out, it looks like the word sin, but unless you're in religion class, we're going to think of that as sine. I could look at this triangle and say that the sine of angle A is going to be 91 over 109, just the fraction 91 109ths, because I go opposite over hypotenuse. The sine of B would be 60 over 109. Again, opposite over hypotenuse, that's the sine.